Here is an explanation for the answer to final exam question number 83 in Electricity Demystified, 2nd edition. If you have the printed book, please see page 340. The question goes like this. Imagine a long, thin, straight wire that produces a magnetic flux density of 8.00 times 10 to the -7th Teslas. That's what that uppercase T stands for. At any point 120 millimeters away from the wire. So suppose we have a point about there. Suppose that's 120 millimeters. Suppose that the wire is suspended in free space and no other objects are anywhere near it. So we get magnetic flux lines, which actually take the form of concentric circles, all centered on the wire. If we consider a cross-sectional plane that runs perpendicular to the wire, and we look at the magnetic flux in that plane, we will see these concentric circles. Where we won't actually see them, but mathematically or physically or theoretically they are there. What is the flux density at points 480 millimeters away from the wire? Well, that's 4 times as far. So P1, point 1, is at a distance of whatever, and P2, point number 2, is 4 times as far away. Remember, the original flux density was 8.00 times 10 to the -7th Teslas. Well, you can go back and learn about this on page 239, starting on page 239. And it goes on to describe these phenomena, and on page 242 there is a formula that will tell you that the flux density near a straight current carrying wire like this varies inversely with the distance, not according to an inverse square law, but simply an inverse relation. So if we go 4 times as far away, we will cut this flux density down to 1/4 of what it was. 1/4 of 8.00 times 10 to the -7 is, of course, 2.00 times 10 to the -7. And that turns out to be choice B. Choice B. So remember, around a current carrying wire, straight current carrying wire, as long as the current remains constant and there's nothing obstructing or moving in and out of this region to disrupt this flux, the density, the flux density, varies inversely with the distance from the wire as we would measure it perpendicular to the wire. Again, the answer here is B.